In this video, we are just going to see how some of the concepts we have learned about throughout the course are used with modules. And in this example, we will grab one of the greatest versions of our BoxContainer class that we have built and compile it as a module and use it in the main CPP file. And to take a class template and turn it into a module, all you have to do is use the export keyword before your template declaration. So here we say export template and say type name. We put in our concept as you see here, and our class is going to show up just below this as it was as a header. This is really all we have to do. Of course, you have to comply with the module syntax. For example, we have the module thing here. We have our module declaration. We have the global module fragment on top here. Below here, we have the preamble where we can do our imports. And all this below here is the preview, which makes up our module. Of course, it is this class template that implements our BoxContainer here. If we go down, we'll see how this module is used in the main CPP file. We are including the headers that we need. And again, I included these because I got a bunch of errors when I tried to compile them as header units, especially with Clang. So I had to stick to including these things to get the code to compile on all the compilers that we care about in this chapter here. We are importing our module. Again, notice the naming here. This is how we named our module, and it is not necessarily the same thing as the name of the file that contains this module. This is something you should be careful about. And in the main function, we are simply creating our BoxContainer, adding stuff into it, and trying to see if it works with random access iterators. And this brings us to the point that I had forgotten to bring up. It is that we used the BoxContainer version that uses random access iterators. If you want, you can grab the code from GitHub for this lecture here, and you can use it as a starting point. Now that we have covered this, I think it is high time we headed over to our IDE and saw this in action. Okay, here we are in Microsoft Visual Studio. The current project is 4811 BoxContainer module. We want to do our BoxContainer class as a module. If you don't know what BoxContainer is, it is a class we built from scratch to build our own container, and it is covered extensively in earlier chapters in the course. Here we will just be trying to compile it as a module. As we have said, we have our main CPP file, and if we go to GitHub, we will see the files that make up this project here. So we have a BoxContainer, an interface file, and the main CPP file. Let's create the interface file on our local system here. So let's do add. You already know this. This must be becoming second nature now. So let's say BoxContainer. It is an interface file, and we have the main CPP file. Let's go back to GitHub and copy the BoxContainer interface file, and we will put the code in here to save on time. Okay, it is pasted in here. And if you go all the way to the top, you see that it is everything we have seen before if you watched the chapter on building your own container class. The only thing I changed here is adding the export keyword in front of this template declaration here. And it is going to be a valid module. And what this says is that this class is exported for use by anyone who imports this module here. Notice that we are including the concepts header because this is a concept we are setting up here. Okay, that requires keyword, and we are importing IOStream because we can, and this has proved to work well with all the compilers that we care about. Now that we have this in place, we can go back and grab the main CPP file. We copy it, and we go back to our main CPP file in the IDE, clean up and put in the new file. Notice that we have a few squiggles. This is because we haven't enabled C++20 because that's how you get access to modules in this IDE. We can do that. We have done this 1,000 times by now. So let's go back to language and choose a C++20. And we can go to general here and enable scan sources from module dependencies. We set this to yes. Click OK, click apply. And if we build, we'll see what happens. Let's build solution. We can see the tool scanning for module dependencies. It is going to start compiling. It will compile the IOStream header unit it will compile BoxContainer, and I named it BoxContainer. What did I do? Let's rename this BoxContainer. I think this is going to do. And do we need to change anything else? Let's see. Let's build and see if we need to change anything. I don't think we do, because the module will be found in the file that contains it. So the name of the module file doesn't matter, but it matters for other compilers that we will try here. And this is really it. This is how you make a class template, a module, and export it for use by other modules in your C++ program. Here I have the instructions to compile with other compilers we have access to. We just saw how to use Visual C++, but if you want to use GCC, let's do this. Let's copy this and go to our PowerShell. Our PowerShell has access to G++. If we do G++ version, it is going to tell us the version that we have installed from WinLabs. And we can do ls to see what we have. And the files that make up our project here are BoxContainer and main.cpp, as you see here. We also have our README file, which contains our instructions here. So we can copy the first command here and use it to generate the PCM or the BMI for our header unit. It is going to go through. Let's compile BoxContainer, not cat. We're going to put it in and see how it goes. It is going to compile. We can generate our binary by putting everything together. Again, putting in the command, hitting enter, and waiting. If we do ls, you will see that we have our rooster binary that we can run. Now we can run it, and it is going to do whatever it does in the main CPP file here. This is how you use the GCC compiler. I am not going to show you how to do it with Clang because it is essentially the same, but for completeness, let's try to do this. I am kind of used to already putting in these commands, so let's do it. We have been doing it all along. So let's remove the mess that was left in by GCC. We can remove any object file and remove rooster and remove the GCM folder. Okay, we already know this, and we can go to the command prompt and paste in the commands for Clang 16 here. Again, remember to use the command prompt. So let's grab this, and you see the note I have put here. Please read it. I am including concepts, vector, and algorithm because I had problems with Clang if I tried to use them as header units. They clashed with IOStream, and I had all kinds of errors that I didn't really want to deal with. So I am just including them here. And where am I including them? You see we are including concept here. If we go in main CPP, you see we are including algorithm. This is what I mean here. Let's go back and grab our command. We copy this and go to the command prompt, put it in, and it is going to go through. Let's grab the other one to compile our BoxContainer. Notice the naming convention here. Okay, we are compiling the BoxContainer.ixx file, but the name of the PCM has to match the name of the module exported from this module file here. This is really important to remember. Let's go back and put this in, hit enter. It is going to compile our PCM. Let's grab the third line here and put it in here, hit enter. It is going to compile our object file. We need to compile the module, and let's put this here. It is going to be compiled, and we need to generate our rooster binary. We can grab the command and put that in and hit enter, and it is going to be generated. If we do dir, we will see everything that we just generated. Rooster is going to be right here, and we can run it, and it is going to do whatever it does in the main CPP file. Now we can hop over to Clang 18 inside our Docker container that we are connected to through this PowerShell window here. And we can remove the junk that was left in by Clang 16 on Windows. We can remove any PCM file and remove any object files and remove any or remove the rooster binary. And if we do lsalh, we will see our files here that are our starting point. Let's go back here and copy the commands. It is a matter of copying and pasting really. Once you have these commands, The hard work is figuring out or putting together these commands. Now we are compiling our BoxContainer PCM. Okay, so let's put this in. Let's grab the other command, which is going to generate the object file for the main file. And notice that with Clang, we have a way to specify the location of the PCM files. You use the fmodule file system. And notice that for Clang, we have a way to specify the location of the PCM files. I got to this by reading the documentation anyway. You can go and search for this flag in the Clang documentation, and you will see how all these things work. Using the documentation is a superpower, as I say in many of my courses and books. Let's put this in. This is going to generate our object file, and we copy the last command, which is going to generate our rooster binary. Okay, if we do lsalh, we will have everything we have generated, including our rooster binary here. And if we run it, it is going to do whatever it does on Linux, and this is really cool. This is really all I had to share in this lecture, showing you how you can set up a class template inside your module and export it for use. It is really not difficult, but this has the potential to improve your compilation speeds, which is the main point of using modules in your C++ programs. I am going to stop here in this video, and I will see you in the next one.